right now I'm starting a pulse or positive pulse tool, in which the different components, before putting it together and torquing and assembling the tool, you have to do a check. So we're at the very bottom of the tool, which kind of helps in combination with the pulser and generates the pulse, is this piece. It's called bottom end. So technically what it is just a sleeve inside here, a ceramic sleeve, very, very slippery. So it's like a piston here, and the piston will move back and forth by the pressure limitation, and which is initiated by your pulser, and this will move in and out. This piece, like inside there is a spring, and this will move in and out like this, and then when it moves in and out, reciprocates, and that's how the back pulse will generate. Check that we have to do is just because these are torque, and the torque lock applied, that glue applied in right here in this thread, so we are not going to torque this, and we are not going to touch these threads when they arrive from shop, or after you rebuild them in the field. And there is a test for this piece. It's called suction test. So suction test, basically what it is, you have to make sure as I said, sleeve and that piston inside are sealing good enough to make a strong back pulse or pulse for your Pulse MWD. For that reason, if you want to check that, what you do, you just put this end on your mud boot or boot or somewhere that is sealed, and then press down, and then put your hand on it, and then release it. So press down your hand, pick it up, and you have to feel a vacuum, like a suction inside. So if you feel that, it means this piece is in good shape to go for using in your string. Otherwise you have to change it, or you have to rebuild it. Next piece is a little jar in your pulse string or Pulse MWD string. It's called like shock reduction tools or different names for it. So basically there is what you want to do, the function, the pre-assembly checks are just, there is a hole through this. So you have to just make sure this is open, and just visually check that hole is open. And the next is just to fill this. It's not loose, or because these are two parts and different put together, different pieces put together. So you just want to do a little wiggle, make sure it's tight and not wiggling, not very loose, nothing crazy. If it's not, then that's the only two checks you do, other than the threads and stuff like that. So I've done this on two stands. This is my pulsar, and then after that I'm going to connect the gamma battery DU and shock reduction tool to this piece, and then at the end I will do that shock tool, a little jar, and that bottom end. One other component that I didn't tell you about is this wipe monitor, and this is a combination of two probes. One is called the wipe monitor, and the other is your spare point. There are 5 or 6 things that you need to be doing while assembling your string. So have to always keep these protectors clean, especially in muddy, and snowy and wet condition, because these connections or douche connections will be very sensitive to wet and dirt, and if wet and mud and dirt goes inside these, then you won't get a good connection, and then your tool fails. Is checking the threads are clean. If it's not clean, then I bring a rag, or like a piece of clean, like feel clean piece of rags, and then you just clean that. Make sure there is no debris, dirt and mud on your thread, because it will invade. Mud will be invaded inside, and then you will have a tool invasion by mud problem. So your tool fails and you have to pull out a hole, and probably you have to pack your bags. So first check is your threads clean. The second is to check the O-rings. I already changed the O-rings here, so make sure on every job is recommended to change the O-rings, because these are cheap like O-rings, and then but it saves you a lot of money and headache and stuff like that. So check your O-rings, just put them back together, turn it, make sure this red line is not visible. See, there is a red line right here, so you have to make sure the red line is passed and covered, and you go a little, like, just do a little, make it tight. So what you want to do, you want to just make it aligned, 2 probes aligned to each other, and then after alignment just use one stand, because with one stand it's easier to put them and like turn it inside, and then put these 2 probes together. That component is my pulsar, my actual pulsar. So based on the manufacturer recommendation and different manufacturing and patent and whatever they have, they recommend different checks. But one check is done with this little Allen key. So what it is, you go to your pulsar, and there are a few holes on this part. There is a membrane right here, the bladder, with hydraulic inside, hydraulic fluid. So what you do, you have to just push it gently with this blunt end. So with the blunt end, you just touch it, and you have to feel spongy. If that's spongy, it means your bladder has fluid inside, that hydraulic inside,
and it will work. Otherwise, the tool may work on the surface when you do the bank test, but when you run it downhole, it will not. So this is the procedure. I mean, the the mechanism of working of this pulsar. Other pulsars and other positive Pulse MWDs may have different. So this little thing that we'll talk about it later, right here, there's a screen, and behind that screen there's a Poppet. So that Poppet, I don't know if it's visible. So that's a little Poppet inside. That Poppet will do reciprocate in and out. And okay, for tap test, as explained earlier, I had to do the tap test, check that my pulsar Poppet is moving, and then I take out these two screws and then take out this screen and then put a little my finger on this. So I put my finger on this Poppet inside, and with a little pressure of finger, it still need to be, the Poppet should be strong enough to move my finger back and forth. And the light test, for the light test, I use a flashlight. I put it right here, and as the pulsar goes in and out, there is a seal right here, and that seal will open and close this, and then I can see a light coming through. So if I see the light and it's light dark, means like that seal is good enough to making that pulse system working for me downhole. So for that reason, I combine two together. So I do tap test a lot, and it depends on your tool memory and the settings and everything. For this tool, it's like 1 minute. Like after 30 seconds, first I see a few cleaning pulse, and then after that I have to see if I start tapping with this mallet right here or anywhere on the tool, so that you'll see. Yeah. So it means my tool is now all communicating, connected and everything. There you go. Yeah, right there. So means tap test pass, tool, light test pass, and finger test already done it, so it will pass as well. So that's the Poppet inside, which is connected right here, and then there is a seal inside. So that's all about it. And these ports are, there's like a hydraulic fluid inside here behind these ports, as I explained earlier. So we did that bladder test as well. Okay, so after connecting this cable, which go into my shack for programming, and this is pretty much the tool that we built and made ready for next hole to drill. And another point that I want to talk about here is the fins. So the fins, there are two types of fins in high temperature and low temperature fins. So low temperature fins are what you see right now. Here on almost every probe we have one fin, which their function is to centralize tool and minimize and to give the stability and minimize the vibration, which is a bit detrimental for our tool. Another thing that we have to always notice for bottom landing tools, which is this one. For bottom landing tool, the fin directions are clockwise. So if you look at this fin right here, so the fin direction is like clock. They are rotating like that, clockwise. This is for bottom landing tool. Unlike my other tool, which was previously here, that was a top landing tool. For top landing tool, what they say, the fins should be installed anti-clockwise. And the other thing is the relation between the fin size and your color or your non-magnetic color. So if you have 8.5 inch or more color size, you don't need to cut these fins, right? Like this one, it's not cut, it's a full gauge fin. But if I do want to run it in the 6.5 inch color and smaller, see, 6.5 inch color and smaller, then I have to cut the fins to make it small so these are the, you see, it's very, you can see it, like the fin size are different for different color size. For 8.5 inch and bigger, don't need to cut. For smaller than that, we just cut with our fin cutter. Okay, so after putting all the props together and torquing it and high-siding it, we can now connect our programming cable to, so that's like a crossover, can go from male to female right now. So I just can put this together and do the programming, which is this going from my cable hole into the shack, so that I connect it to my MWD computer and laptop, and then I do the programming with a software that are patents of every company's. This is our end products or our end of work, how our tool look like. So you see all the components, and it's something between 10 to 12 meter depending on number of the probes. On this typical tool we're using one battery, and the probes are almost seven probes put together, 7 components put together to make this tool string. And one piece of other equipment that we use here for testing it after programming and configuring and reading tool configuration from the tool's memory, we have to do the roll test, which with that level we do high side 90 degrees and 180 and 270 degree roll test. So when we do roll tests, what we basically do is this is the bottom hole, bottom end of tool. So bottom end, so means this is the downside of the tool. So for uphole, from uphole, if you look down, this is your high side. This is 0 degree or high side gravity tool face. This is your 90 degree right. This is your 180, and when you rotate it back, this is 270 or 90 left. 90 left tool face. This is 4-point roll test. If you turn it back to high side, that's called 5-point roll test. So roll test in fact is like a slight simulation. So you simulate your tool, you turn the tool to different tool faces and read the counts. You read the magnetometer and accelerometer counts and make sure the tool is functioning properly. So that's a kind of function testing the tool. We have for function tests we do a few tests called roll test, tool test, and then after high siding the tool we do roll test, tool test, and flow test. So these are just to make sure the tool is functioning properly. But what we do is a function test of the tool, so, or a flow test, what they call it. For flow testing means the tools, like we have to simulate the pumping condition downhole, which tools start to vibrate, and for that vibration we have something called like sander, which this vibrator, it vibrates and shakes the tool, and tool thinks that it's really actually pump, and then when it stops pumping, it flow detector or flow sensor detects the flow and starts to command the DU, and then DU sends the gamma, and DU sends the survey, and this gamma probe will also record gamma and send it via this cable, send it via that cable which we're connected here to our MW laptop. After making the tool and everything is ready, we have to do a few measurements right here. So one of the measurements are from our reference point. Reference point in this tool is right here. So from here, we have to measure the distance to our gamma probe or gamma sensor location. The gamma sensor location on this probe is 30 inches from the pin connection. So this is the pin connection. If you measure like 30 inches, like about here, and then this is the distance when you measure from for gamma sensor location. And then if you walk pass through battery, and then I have the DU or directional unit here, and about 34 inches from the pin sorry, from the pin connection. This is the pin connection on DU. So about 34 inches right here. This is how much is the length of the gamma of the DU or directional unit or survey sensor location. So this is how much back plus the length of the length of mule shoe, and then or UBHO plus the length of UBHO. You have to do some calculation and put your, if you have monol and you have motor, and then you have the bit length. So then you can calculate almost about 16 to 17 meter on this tool for gamma for DU or survey point offset distance from bit is 17 meter, and for gamma is about like 14 meter.